Alright, Chapter 7, Destructive Testing. In destructive testing, sample portions of welded structures are required. These samples are subject to loads until they actually fail. The failed piece are then studied compared to known standards to determine the quality of the weld. Most common types of destructive testing are free bend, guided bend, nick break, impact fillet weld, joint etching, and tensile tensing. Testing. Primary advantage, disadvantage of the destructive testing is actual section weldment must be destroyed to evaluate the weld. This type of testing is usually the certification process of the welder. Some of the testing requires elaborate equipment not available to use in the field. These tests that may be performed in the field without elaborate equipment are the free bend test, guided bend test, and the nickel break test. Alright, the free bend test is designed to measure the ductility, weld deposit, heat affected area adjacent to the weld. Also, you determine the percentage of the elongation welded metal ductility. You should recall is that property of the metal that allows it to be drawn into or hammer thin. First step, preparing a welded specimen is a free bend machine is a welding reinforcement crown flush would serve as the test plate. With a welded area with the test plate is machined, as in case of the guided bend as well with the free bend test, performing the machine operation opposite direction to that of the weld deposit. The next step of the free bend is test. Describe two lines of the face of the filler deposit. Locate these lines, and then so figure 16761 shows the specimen, the preparation, the testing, and along D the elongation face and field weld elongation. Guided bend test jig. 1/16 of an edge, and each edge of the weld metal shown figure 761. View B, measure the distance in inches between the lines of the 1,000 inch. Let the resulting measure equal X. The bend ends test specimen until each leg forms an angle of 30 degrees. Original center line. The scrub lines outside of the piece of the place and when the bending occurs, the weld bend the test speed with the hydraulic pressure. Similar machine precautions are taken when the blacksmith forging hammer can be even complete the bending operation. If a crack more than 1/16 of an inch develops over the test, the stop of the bending because the weld has failed. Otherwise, bend the specimen flat. After the completing of the test, measure the distance between the scrub lines and call the measurement Y, the percent of the age elongation with determination by formula. Alright, 763 shows the guided bend test specimens, the root bend, face bend. You have a root and a face, requirements of satisfactory test area between minimum elongation, 15%, no cracks greater than 1/16 of an inch in face weld. Guided bend test. Use a guided bend test to determine the quality of the welded metal face and root and a welded joint with the test made. A specifically designed jig, and an example of one type of the jig is shown in figure 762. Test specimen is placed across the supports of the die. The plunger operated above the hydraulic pressure forces the specimen into the die. The fulfillment requirements for the test must bend the specimen 180 degrees of the capacity of the jig. No cracks should appear on the surface greater than 1/8 of an inch. Face bend tests are made with the jig in the face of the weld with the tension outside. Figure shown figure 763. Root bend testing are made with the root weld and tension outside shown 763. 764 shows the machine used for making guided bend tests and used in many welding schools. 764 test machine welding guided bend test. 765 nick break test on butt weld, base weld blocks with specimen, and the test specimen strikes for here, press here. Testing laboratory daily testing specimen, simple construction, easy to use. The works hydraulic pressure can apply with a direct load up to 40,000 pounds, even the more small specimens. Make test position of the specimen in the machine. Previously indicate the starting pump of the actuator. Keep your eyes on the large gauge. Watch the load increase. You know the actual load under the test piece bends in position. Auxiliary hand and carried along with the gauge pointer of the hand remains at a point. Minimum maximum load after the pointer returns to 0. Nickel break test. You determine the internal quality of the welded metal. The test reveal with the various internal defects, if present, such slight inclusion, gas pocket, lack of fusion, oxides, burned metal. Complete the nickel break test. Check the butt weld. You must first flame cut off the test specimen and sample of 765. Make a saw cut at the edge of the through the center of the weld. The depth of the cut should be 1/4 of an inch. Next, place the saw nick specimen on the two steel supports and using a heavy hammer break the specimen in by striking it into the zone where you can make saw cuts. The welded metal exposed on the break should be completely fused, free of slag inclusion, contain no gas pockets greater than 1/16 of an inch across the greatest dimension. There should not be more than 1/16 6 pores and gas pockets per square inch of the exposed broken surface of the weld. Impact test. Impact test to check the ability of the weld to absorb energy under impact without. A shows the Sharpie notch of radius of 1/10,000 of an inch, 315,000 of an inch, 394,000 of an inch, and shows the notches. Test piece of the impact studying. Pendulum force striker specimen supports. Pendulum striker force specimen support. 767 performing impact testing. Factoring the dynamic test in which test specimen is broken single below the energy used in breaking a piece of the measured foot-pound of the test compared with the toughness of the weld metal with the base metal, with the useful finding in any of the mechanical properties of the base metal will destroy the welding process. Two kinds of specimen give the impact testing shown as the Sharpie ISIs. Both types of piece are broken in impact testing machine. The only difference is that they are anchored in Sharpie test support with the horizontal between two anvils, palladium strikes opposite of the notch. Shown in figure 767, view A, ISI's piece of the support vertical cantilever and a struck on the free end of the project of the holding vise. Figure 767, view B. Alright, your fillet weld joint test. Using a fillet weld joint test to check the son's fillet weld soundness for the degree of the freedom weld has defects. And on a visual inspection exposed welding surface with defects include penetration, gas pocket inclusion. Compare the test specimen shown in figure 768. Now apply with the force at point A. So it shows the length at 4 inch, 6 inch maximum, 5 inch approach. TT equals F plus 1/8 inch. Minimum length of the weld is length minus 1 inch. 4 inches, and you have your fillet toes and T. Rupturing a fillet weld test. The force is done. 769 until the break occurs on the joint of the force may be applied with a hydraulic hammer blows or hammer blows. In addition, checking the fracture weld for soundness is done. Good time to each edge the weld to check the cracks. Edge testing. Edge testing you determine the soundness of the weld. Make also visual boundary between the base metal with the weld metal to accomplish the test. You must discuss the test beat of the weld. The joint show the complete transverse section of the weld. You can make the cut with either solid flame cutting. Follow the face for the cut, then polish it with a grade of 00 abrasive cloth. Now place the test placement in the etching sketch. Etching solution generally either the hydrochloric acid, ammonium persulfate, iodine, potassium iodide, nitric acid. Each solution highlights different defects areas in the weld. Hydrochloric acid dissolves slight inclusion in large and gas pockets, while nitric acid is used to show a refined zone as well as the metal zone. Alright, your tensile strength test. The term tensile strength test may be defined as resistant longitudinal stress pull with a measured per pounds per square inch in cross-section testing. Tensile strength involves placing a welded sample in the testing machine, pulling it on the test sample until it breaks. And figure 770 shows the chain test specimen, gauge length, reduced section. Testing essential features of the tensile testing machine as part of the pull test of the specimen. The device that measures resistance of the test specimen and another instrument known as the extensometer on the strain gauge also with the measure strain in the test piece. Some equipment comes for the device record and plot strain, stress strain curve with a permanent record. Tensile tests are classified as a destructive test because the test specimen must be loaded and stressed until it fails. Because of the design of the test machine, weld samples must be machine-specific dimensions. This explains why test is made in standard specified rather than on the part itself. It's important that test specimen represent the part. Not only most of the specimens give it the same heat treatment as part of it, but also must be heat treated at the same time. There are many standard types of the tensile test specimens. Figure 770 show the one standard type of the specimen commonly used. Standard test piece of the actual accurate machine specimen. Over length is not a critical item, but the diameter gauge length and R 505,000 inch of an inch or 2/10 of a square inch cross section in the reduced portion provides easy factor maintainably or arithmetically. 2-inch gauge length is distance between strain measuring points. This is the portion specimen when you're attaching extension meter. In addition, you can use the gauge length to determine the percent elongation. Tensile amount to apply to smooth, steadily increase the load or pull the test specimen, measuring the resistance of the specimen until it breaks. If the recording equipment is not available, this is the test Not difficult to perform. During the test, you observe the behavior specimen on the record, extometer, gauge readings at regular intervals. After specimen breaks, fracturing load is required. Record measuring the specimen calipers determine the percent elongation and percent reduction in the area. In addition, you should plot a stress strain curve. The data obtaining the determine tensile strength. Yield point, elastic limits module, elasticity, other properties of the material. Safety regulations. You as a welder must have the thorough knowledge of the safety precautions relating to the job. That's not all. You should also consider the responsibility to observe the applicable safety precautions when welding. Carelessness can cause serious injury to yourself as well as others. Bear in mind safety precautions for operating welding equipment considerably because of the different type of equipment involved. Therefore, general precautions of the operating metal arc welding equipment are presented here. For specific instruction on operation maintenance of your individual equipment, consult with the equipment manufacturer instruction manual regardless of the general precautions. Know your equipment, how to operate it, use it, only provide welding equipment to ensure that it is maintained properly. One, before you start reading, ensure the welding machine frame is grounded and either terminal or welding generator is bonded to the frame. That's all. The electronic current connections are sure. Ground connections must be attached firm to work and not merely laid loosely upon it. Keep welding cable dry and free of the oil and grease. Keep the cable in good condition. Always keep the appropriate stuff to protect from oil from the damage when it is necessary to run cables some of the distance of the machine. Lay them overhead if it is possible. Use the adequate support devices when using portable machines so you're sure that the primary power cables are separate from the welding cables so they not become entangled. Any portable equipment mounted on the wheels should be securely blocked to prevent accidental movement during the welding operation. When stopping work at applicable length of the time, be sure to de-energize the equipment, and when the equipment is not in use, you should completely disconnect it from the source of power. Keep working area neat and clean. If at all possible, make it practical to dispose of the hot electrode stubs in a metal container. Chapter 3 contains information, protective clothing, eye protection, safety practices applicable to personal safety, operator, or other personnel who may be working nearby, but the information will not be repeated here. If necessary, go back and review the section entitled Safety in Chapter 3 before proceeding in the next chapter. Chapter 8, Gas Shielded Arc Welding.